All right, we still have two things to cover. It's how to visualize MLR models and also how to work with interactions. So let's start with visualization. In order to do that, first of all, let me create a new model. In this case, I will have only two predictors. You remember this, when you have more than two predictors, it will be difficult to visualize such a model. So therefore, I will use two predictors. And I will also use the original data, not centered data set. Okay, so let me run it. So you can see that all the estimated coefficients and the results of tests look correctly. Now, the idea of the visualization is follows. You remember that MLR model, it's either a plane if it's a linear model, or it's a surface if you have also interaction term that gives you a little bit of nonlinearity, right? In the three-dimensional space. So what we need to do, we need to generate a grid of x values. So it means that we need to generate, if you think about h and region, you need to generate a lot of h values and region values to make a grid in this space. And then for every point of this grid, we will calculate y value, and then we will use the calculated y values for the visualization. So let me show you this like step by step. Well, first of all, let's recall how big the h is, right? So let me calculate the range of h. So this is the range of h. You can see it goes from 18 to 55. And region, I know it goes from -1 to +1. In this case, using region, maybe it's not a good idea because it's not continuous variable. So in this case, it's better to replace region by something which is continuous. For example, it can be wine, because you remember wine correlates with region. But let me keep it, although it's not fully correct to do that. So let me do it for the region anyway, just to follow the examples that I have shown you in the videos. But you understand that actually you can do it for any variable which is continuous variable. Okay. So first of all, let me generate only 5 values. For example, I call it h equal to, let me call it vh, meaning vector, a sequence which goes from smallest h to largest h, $h. And then I say the length of this sequence should be 5. So I have only 5 values. Length out equal to 5. Okay. So let me generate them and show you them. So this is the 5 h values that cover evenly the range, right, from 18 to 55. So they're equally distanced. Then I do the same for the region. I say v region is sequence from -1 to +1, and then also length equal to, for example, 5. So this is the region values. Okay. Now what I should do, I should calculate all possible combinations in order to make the grid, right? I should calculate all possible combinations. For example, keep h at 18 and then combine it with -1, with -0.5, 0, 0.5, 1. Then take this h and combine with all of them. Then take this h and combine with all of them. So I will have 25 different values, different combinations. Luckily in R, there is a function that does it for me. So I'll just call it, I just use this function. It's called expand grid. Expand grid. And then you simply provide the data as a list. The names of the list items should be the same as the names of these predictors that you use here. So h equal to vh, and then region equal to v region, right? So I provide these two vectors, and then the rest, this function will do it for me. You can see that I have exactly 25 values where, look, first region is equal to -1, and I got all possible h values. Then region is equal to -0.5, all possible h values, and so on. So actually I can make a plot, and then you can see this is, let me switch back to one plot per figure, mf row equal to C211. Then you can see I simply generated a lot of points for every h, and for every region I took all combinations. So now I have 25 different points, 25 different combinations of x1 and x2. Now I will predict y value. For every combination, I will predict y value. How? Well, we know how. So yp equal to predict m, and then look, d is already data frame, right? So d is already data frame that I generated. And now I get 25 predicted values. So this value, it's a salary of this person. This value is a salary of this person. this salary, it's a salary of this person, and so on. Okay. In order to make it a little bit easier to understand, let me change 5 to 6. You will see why in a minute. So we know that we have 6 values for the age and 5 values for the region, right? And then the predicted values, you will see why predicted, will be 30, not 25, right? But if you look at the D, you see that the first predicted Y values, first 6 predicted Y values, it's for the region -1. Then we have for the region 0.5 and so on and so forth. So what I can do, I can make it a matrix. I can say matrix, and then how many rows? Well, 6 rows in this case, right? So I'll just write it here. YP, 6 rows. And then how many columns? 5 columns, right? So if I run it, now you can see I have a matrix. So this value is for this point, this value is for this point, and so on. So this matrix matches, I think it should be, yeah. Sorry, I should change for the plot, I should change let me just do it like this. Let's say it's age versus region, because region should be x-axis. Because you can see I have 5 columns and 6 rows, and then it should match this one, okay? So let me just do it again, data equal to D, like this. So now it matches, you can see. So this is you can see it goes up very quickly because this is the age, right? And then you can see this difference is due to the difference between the region, okay? So now these values matches the points here. Now look, you can visualize it using a heat map, but in this case, I can actually make it just an image. Let me explain why. Let me show the image first, right? You can see you have a lot of kind of pixels, right? And then you have 1, 2, 3, 4, 5, 6 values here, and 1, 2, 3, 4, 5 values here, right? So apparently this is the region and this is the age, right? So I can actually add this information. I can say VH and V region, right? And then you will see that this is the age and this is the region. And then you can see this trend here, right? So the trend goes to the region -1 and to the age 50. So people here have a higher salary, right? But then what can we do? We can actually increase number of values here. So I will, for example, say, let's say not 6 but 60, and not 5 but 50 here, right? And then also 60 here and 50 here. And now if I run it, you can see a much more smoother. And now you can start seeing these contours, right? These are the contours. These are the contours. So instead of showing this like a heat map, you can actually show the contours only, and that will give you the contour plot. Okay. If you write, for example, 600 and 500, 600 and 500. So let me run it again. So now we have really, really many values, right? And now it will take some time, so probably on your computer it will be even longer. And now you can clearly see these contours. So that's kind of a contour plot. Why you have contours? Because by default image, it has limited number of colors. So in this case, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 colors, right? If I say don't use 12 colors, but use more, these contours disappear. But because the number of colors for different Y values is limited, we can clearly see this as contours, right? So every value inside the same color, it's a value where the salary doesn't vary much, so it's almost the same salary. But if every value on the contour, it's a combination of region and combination of age, which has exactly this one single value of the salary, right? Now let me make a normal contour plot. So contour. Then let me make it without the axes first. So this is the contour plot. You can see it has the same direction downwards, right? So to the right and to the bottom, right? And then let me just add the age and the region. And then you can see now you have age and region. You can, of course, add labels equal to age, years, right? And then while up equal to region, And then you will see this with all this with the region and age. You can also change number of contours. For example, you can say use 20 contours, and then I think it's called be n equal to 20. Let me try it. Yes, to n equal to 20. So you can see the number of contours is larger, and then you also can see the real salary value here. Okay. Let's take a salary with 20,000, right? So let's got the coefficients first. So B equal to coefs M. So these are the coefficients you can see, right? And then you know that we would like to get combination of H and region that gives you exactly 20,000, right? So what does it mean? It means that y equal to minus 535.5, that's the intercept. That's the intercept, it's this one, right? Then I know it's times plus 812.3 times H minus 306.13.4 times region, right? Of course, I cannot run it. It's just my mathematical expression, right? So I make it a comment. Now what I can do, I know that y, I would like to have y exactly 20,000. So instead of y, I write 20,000. Let me just make a new line so we can follow this. 20,000, right? Like this. Now what I can do, I can add this value to both sides, so it will disappear from the right, but it will add up on the left, right? So it will be 20,535.5, and here it will disappear, right? Then I can say, for example, I would like to calculate region if I know H, right? So if I subtract this from both sides, I will get the following. Let me just take it from here. I will get, I shouldn't of course remove it, I should copy it. I will get the following, 2535.5 minus this equal to this, right? Equal to this. And then finally, I can calculate region. So I can say region is this. And then I should take it in parentheses, divided to minus 36134, right? Or you remember that these are regression coefficients, right? So what I can do, I can write region is, this is my y value, expected y value, let me call it, plus b0, right? Plus b0, then minus b1 times h, right? And then divided to b2, right? Divided to b2. Now let me calculate it, right? So first of all, I say, okay, let's take h as a sequence, For example, from 18 to 50. Let me just make it like this, for the sake of simplicity. From 18 to 50 to 55, right? So this is different h values. Now for every h value, I need to compute region value to get the y value exactly equal to 20,000. So I say region equal to 20,000, that's my expected y value, plus b0. And in this case, I have b0 here, right? So it should be the first value here. So it will be b first value, it's a b0, minus b second value, it's b1, times h, which I just generated, right? And then divide to b third value, it's b2, right? So now I will, let me just keep it to be consistent. Now I will get the region values. You can see I get the region values. Yeah. And now what I can do, I can make a line. I say a, b, oh yeah, I can make it even points. So I add these points, h, region. And then you will see that they are, oh, not exactly on the 20,000. I don't know why. Oh, I actually know why, because this should be minus b0, of course, right? So this should be minus b0. Because I subtract, right? So I subtract minus 535 from both sides. So now it should be correct. Let me just do it again. And then you can see now they are exactly on this line. So now we found the combination of h and region that always gives you the salary of 20,000. Let me maybe make a new one, and then maybe make it like color equal to red. And now you will be able to see it clearly, right? And this is exactly how this counterplot is made. For example, if I change this to 24,000, right, and then run it, you will see the points around the 24. If I change it, for example, to, I don't know, 36,000 and run it, you will get points around the 36 on the line that corresponds to salary 36,000 krona, right? So this is the way the counterplot is made, okay? And then, as I said, you can also make this colorized counterplot. For example, R has a built-in function. It's called fillet contours. fillet contour, and then you just provide the same values. You say VH, V region, and then the YP values, right? Of course, for contour plot, you don't need that many YP values. You remember we computed like a lot of YP values, right? 300,000 YP values. So you don't need that many, of course, but let me just make it anyway. So that's why it takes a little bit of time, but you can see that this is the again, this is H, this is region, this is the color legend. So you can see how color matches the real salary, right? And then you can actually also add X label, H in years, and Y years, and Y label region, right? Okay. So now you can see it's a bit slow. Maybe I should change this back to 60 and 50, otherwise it will take more time than I expect. So let me just do it. Then I will click source to run everything that I have. Then you can see it looks a little bit, it runs a little bit faster now. Okay. Now I also showed you how to make the surface, right? But actually R doesn't have a nice function to make surfaces, the built-in functions. So what I recommend you is to install a special package. It's called Plotly. So let me show you. Install. Let me just make it here. So packages, install, and then it's called Plotly. Plotly, install. If you go to if you open a browser, let me make it a bit so it fits the screen. Right, like this. So if you go and Google Plotly or use any other system, right? So this is the Plotly. You can see it's by default, it's made for Python, and it also works with JavaScript and so on and so forth. But if you write Plotly R in Google or any other system, Plotly R, oh, yeah, let me just again, Plotly R, like this, okay? And then you will see that Plotly R graphing library in R, you can see this one. Then if you click, you will get a lot of different examples, how to install it, like getting started. And then it tells you how to install Plotly, how to use Plotly, and so on and so forth. Okay. It's not it's not similar to what R uses. It has a little bit different way to enter arguments and so on and so forth. There is another great graphics library for R. It's called ggplot2. So Plotly resembles ggplot2. Then you can see 3D surface plots, how to make 3D surface plots. You can see you just need to provide this Z, and then let me just copy this code here, right? Look, so I already installed Plotly, so I can just load it. And then you can see you need to provide Z. It should be a matrix. And I have this matrix, it's YP, right? So let me just try to run this one. And then afterwards you need also to do it like this. Hop. And then you can see that's the plot, okay? You can see this is the salary. So this is the, and then it doesn't show you what is H and what is region, but that's why I use them different size. You can see this goes from 0 to 60, and you know where we have 60 values, right? We have 60 values for H, you remember, this is it for H, and then 50 values we have for the region, right? So what I can do, I actually can change it. I can provide also X values equal to, so you can see X is where we have 50 values, so it's V region in this case, and then Y it's VH, right? So if you run it, you can see you got the correct one, right? So this is the H. When people get older, they have higher salary. Then you can see this is the influence of the region with -1. It's Scandinavia, people have higher salary. So it looks like it reflects the what we expected, right? And then of course you can also add like labels, title, and so on and so forth. Just look at the documentation for the Plotly in order to find how to do that. You can also actually make a contour plot in Plotly. In this case, you don't need this surface. You just need to say type equal to contour, and that will make a contour plot. And again, you can add labels and titles if you want. But actually, for the contour plot, I think the fillet contours also does a very good job. Now let's talk about interaction. So I will just copy my model that I have here, and then paste it here and run it. So this is the interaction model. Oh, sorry, I forgot to add the interaction term. So this is H region, right? H region. So this is interaction model with interaction. So you can see that the value is different because I didn't use standardized data here. And it's very important that when you make a model with interaction, standardize your data or at least mean center your data. So in this case, it's better to use either standardized values or mean centered values if you have the interaction term. So in this case, you can see that how significant this term is. It doesn't change, but at least it shows the correct, let me use the centered data so you will get it the same as I have it in my slides. It shows the correct correct estimated effect, but sometimes it's also important to mean center because otherwise you will have correlation, high correlation between the individual factors, individual predictors and the interaction term. So if you have model with interaction, always center your data, or even better, standardize your data. That's important. Okay. Now let me just simply visualize this model. I already have H and you remember VH. I already have V region, right? So I will just reuse these two vectors. I just need to make new predictions. YP equal to predict M, and then use the same D, which is, you remember, I'll just show you here, hat D. It's a combination of this H and region that we generated before, right? So now I have YP. It's still, as in previous case, it's a 50 by 60. You remember, let me just show you here. So this is how I got YP for the previous model. Now I can just do the same for the new model, like this. And then if I, for example, show you the contour plots for this new predicted, for the new visualization, you can see that this plot is not linear anymore. So we have like curves. We have a curves. And then if you watched and played with Grasta up, you know why, right? Because now the regression line for every individual, for example, H variable, it depends on the region. So you have different slopes depending on the region, and that makes it a little bit curved. Okay. I can also show the surface. I don't need library, just this one. And then you will see this little curvature on the surface as well. So if you look at this, you can see that there is a little curvature, right? So there is a little curvature. So it's not a plane, it's a surface now. It's not a plane anymore. You can also see it here. So there is a little curvature here, right? So this is the interaction. So interactions sometimes are important for account, but if, for example, if you make a model and there is no significant interaction term, then you can skip the interaction. So you can make a model without interactions. Okay. So that's actually it. So this video concludes the block number 3. So now you know the basics of the linear regression, and you can always learn a little bit more. For example, you can use MLR to make nonlinear regression. You can add quadratic terms and so on and so forth. But the general idea how to build the model and also how to visualize it, how to check the performance is the same as if you use just only linear terms or interaction. Okay. So that's it for block number 3.